day everyone, I am Lanilyn I. Villares, a science teacher and a graduate student pursuing Master of Arts in Education, major in Science Education. Today I will demonstrate one of the approved molecular gastronomy techniques called jellification. Molecular gastronomy is one of the scientific study of physical and chemical transformations that occur during food preparations. It combines principles of chemistry, physics, and biology to create innovative textures, flavors, and culinary experiences. For these demonstrations, we will transform an ordinary mango texture into elegant crystal mango agar cubes using agar, a natural hydrocoloid extracted from seaweed. While preparing this dish, I will explain the chemistry behind each step so that we can understand not only the gel forms, but also why it forms. This will be our learning objectives. By the end of demonstration, you should be able to: number 1, explain what hydrocolloids are; number 2, describe the process of jellification; number 3, explain the role of temperature in gel formation; and number 4, describe how hydrogen bonding creates a three-dimensional gel network. Before we begin, let us observe proper laboratory and food safety practices. First, wash your hands thoroughly before handling food. Next, wear appropriate protective clothing such as an apron and hair restraint. Next, handle hot equipment carefully to avoid burns. And finally, use only food-grade ingredients for edible preparations. For today's activity, we will need the following materials. First, 1 sachet of Mr. Hot Yellow Gulaman, which is made from seaweed extract, 4 cups of water, mango-flavored milkshake mixture, sugar, which is optional depending on your desired sweetness. We will also need a saucepan, measuring cup, whisk, mold, knife, and serving plate. The most important ingredients in today's demonstration is agar. Agar is a hydrocolloid, meaning it interacts strongly with water and changes its texture. It is primarily composed of agarose and agaropectin, 2 natural occurring polysaccharides extracted from red seaweed. Because agar is a polymer, it has the ability to form a stable gel when heated and then cooled. First, I am pouring 4 cups of water into the saucepan. Next, I gradually sprinkle the agar powder into the water while continuously stirring. This allows the agar particles to hydrate more evenly, ensuring a smoother gel. Next, I am adding the mango-flavored mixture to provide both color and flavor. Notice that the solution remains completely liquid. At this stage, the agar molecules are dispersed throughout the mixture but have not yet formed a network. Now, I will heat the solution while stirring continuously. Heating supplies thermal energy that separates the agarose polymer chains. As the temperature increases, the molecules become more mobile and dissolve uniformly throughout the liquid. This stage is called the sol state, where the hydrocolloid is completely dissolved in the liquid. The solution has now reached boiling temperature. At this point, the agar molecules are fully dissolved. Continuous stirring ensures that heat is distributed evenly and prevents localized overheating. I will now carefully pour the hot solution into the mold. Although the mixture is still liquid, The molecule transformation will begin as soon as it starts cooling. As the temperature decreases, the agar molecules begin to reorganize. Hydrogen bonds form between neighboring agarose chains. These bonds create a strong three-dimensional polymer network. Water molecules become trapped within this microscopic network, producing a firm gel without freezing. Once fully set, I will carefully cut the gel into uniform cubes. The gel maintains its shape because the polymer network resists deformation while holding water inside. Now, our crystal mango agar cubes are now complete. This elegant presentation demonstrates how molecular gastronomy combines culinary creativity with scientific principles. Jellification is widely used in molecular gastronomy to create artistic desserts and unique food textures. Beyond the culinary world, agar is also used in microbiology as a culture medium, in pharmaceuticals for capsule production, and in the food industries for jellies, confectionaries, and processed foods. Today, we successfully demonstrated the molecular gastronomy technique of jellification by transforming a liquid mango mixture into crystal mango agar cubes using agar, a natural hydrocolloid derived from seaweed. Throughout the process, we observed how heating dissolved the agar polymers and how cooling allowed hydrogen bonds to form a three-dimensional network that trapped water, resulting in a stable gel. This activity shows that chemistry is not limited to the laboratory. It is present in the foods we prepare and enjoy every day. By understanding the scientific principles, we gain a deeper appreciation of how science improves both our daily lives and culinary innovations. Thank you for watching, everyone!